Hi guys, this is Ashrith Edukulla, and in this lecture we are going to learn polynomials, the first lecture of IOQM revision and AIME revision. And this whole course has approximately 18 into 3 54 lectures. So every day you're going to get 4 lectures. Each lecture is going to be 30 minutes, one for the theory, one for the basic problem solving, one for the advanced problem solving, and one is AIME, AMC, and IOQM previous problem solving. So let me show you my the sheet. So you can see all the lectures I'm gonna update from December 20th to, so the dates might be changed, okay? It might be December 1st also. I'm recording it before 1 month, 1.5 months. So I'm gonna update it here. So you can see you have 8 classes of algebra, 2 of polynomial, 2 of quadratic, 2 of sequence and series, 1 of inequality. Sorry, 7 classes of algebra, then 5 classes of number theory, and then 2 classes of combinatorics and 4 classes of geometry. And we are also giving 2 mock tests. And on January 9th we have IOQM, and on February 10th, I don't remember the exact date, but in February 10th or something, we have AIME. So our goal is to cover the whole syllabus before IOQM, which is January 9th, and we can do some problem solving more for AIME. So in this class we're going to learn polynomials, and make sure you this is like full theory class. So as I told you, you'll have 4 classes. So the first class will be theory, the second class will be of basic problem solving, third will be advanced problem solving, and fourth one is going to be previous year problem solving. So this is the first one, which is theory. So what is a polynomial? So just a second guys. Yeah, let's start. A polynomial is something which is in the form of an x power n, x power n minus 1, an minus 2 x power n minus 2, so on, up to a1x plus a0. Here, an cannot be, it cannot be 0. An cannot be 0 because our degree, means the highest term of the polynomial is n. If an is equals to 0, then the highest degree will become an minus 1. So we don't want it defining in such a way that we want a degree to be n and an minus 1 not equals to 0. So an minus 1, an minus 2 up to a1 and a0 are the coefficients. So these coefficients can be real or imaginary. And the highest power of variable in p of x, this is a p of x, and the highest power of the variable x is n, obviously, because n minus 1 is obviously less than n. And n minus 1, n minus 2, n minus 3, all are positive integers. So okay, you can take it as whole numbers, all are whole numbers. And if an equals to 1, as I wrote here, if an equals to 1, if the leading coefficient, which is an, equals to 1, then we call the polynomial p of x as monic polynomial. So I have classified few polynomials. So there are many types of polynomials. Zero polynomial. So this is just for the sake of notes. Oh, 1 second guys. Yeah. So a zero polynomial is with non-defined degree. It's which has a non-defined degree. So example, 0 into x power n equals to 0, 0 into x cube equals to 0. So we don't know what the degree is here, because if we multiply anything to 0, then we get obviously a 0. And a constant polynomial has a degree 0. Many people will get confused between these two. So phi into x square, x power 0. What is x power 0? Phi into x power 0 equals to phi, because x power 0 equals to 1. This is equals to 1. And phi, okay, let us take something else. 73 into y power 0. Y power 0 is again 1. So 73 into 1 equals to 73. So in a constant polynomial, the degree is 0. So linear polynomial. So with similarly with linear for a linear polynomial, we'll have a degree 1, quadratic will have a degree 2, cubic will have a degree 3, and for a biquadratic will have a degree 4, and anything above 4, some people call it pentanomial or hexanomial, etc. But I just no, we just call no, you can just call it polynomial. You don't need to go into deca polynomial, all that. So let's go to the next slide. So what's a division algorithm? So a division algorithm, one second. So a division algorithm is something what we use in actual division, maybe in a smaller classes. We used to write. So when we were given few numbers like 17 and divide by 5 and find the remainder, we would just say the quotient equals to 3 and the remainder equals to 2. So the so it's a really common thing what children do is 17 and then divide by 5 and then uh, subtract 15, which is they take 3 here and I get a 2. So what I'm doing is I'm taking a relation between this one, this one, this one, and this one, the remainder, divisor, quotient, and remainder, and I'm writing it like this: dividend equals to divisor into quotient plus remainder. So here's an example below, you can see, and the degree of remainder is always lesser than the degree of divisor. See, when you're dividing something, okay, take any number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and divide all of them by 5. When you divide all of them by 5, you get this will give these two will give a remainder 1, these two will give remainder 2, these two will give remainder 3, these two will give remainder 4, and this will give remainder 0. So you can observe that all the numbers are less than 5. All the numbers are less than 5. So I'm just generalizing it such a way so it's easier for you to understand. So all the remainders are less than 5. They're from 0, 1, 2, 3, and 4. So if I'm dividing it by 9, I'll have remainders from 0, 1, 2 to 8. I can't have a remainder 9. So in number theory is different. We assume remainder 11, 12 also. And the concept of negative remainders also will come there. So for that, you just got to wait till 8th lecture. You're going to get it. And the division algorithm for polynomials. So in polynomials, so division algorithm is written same for polynomials where I take the dividend as some polynomial. I'm assuming the dividend as f of x, divisor as p of x, quotient as q of x, and remainder as r of x. So these all are polynomials. So normally we are using all numbers, right? So instead of numbers, we can use some polynomials also. Same like x cube plus x square plus x plus 1 equals to x plus 1 into something plus some remainder. So it's same for them also. So roots or zeros of polynomial. If a polynomial p of x is equal to 0 for some value of x, then we say that x is a 0 of the polynomial p of x. So example, I have a polynomial x minus 1. So one second guys. I have a polynomial f of x equals to x minus 1, and when I keep x equals to 1, then f of 1 equals to 1 minus 1 equals to 0. So then I can say, so if I was given in different way, if I was given that f of 63 equals to 0, then that implies x minus 63 is the root, or 63 is a root, because so I mean one of the factors is x minus 63, because when I keep if I keep 63 here, then I get 0. So it can be q of x into 63. So the q of x can be anything, because if one of the term becomes 0, then everything becomes 0. And then comes the value of polynomial. uh, 1 second guys. So if I have a polynomial p of x such that p of x equals to x cube plus x square plus 3x plus 1, and you want to find the value of polynomial, sorry, so if you want to find the value of the polynomial at x equals to 2, then just replace x by 2. So wherever you have x, then replace it by 2. So then p of 2 equals to 2 cube, which is nothing but x cube, 2 square plus 3 into 2 plus 1. So obviously can't replace anything with 1. So obviously 1 has to be 1 because there is no variable there. So when I sum it up, I get 19. So the value of p of x at x equals to 2, the value of x equals to 2 is 19. So these were really simple concepts, guys. So I'm moving on to the next slide. So remainder theorem. So what is remainder theorem? Remainder theorem is nothing but the division algorithm. So in remainder theorem, 1 second. In remainder theorem, I'm just taking the division algorithm. I have taken the division algorithm, and I have, as you can see, I have written it in the form of the polynomial terms. I mean functions like p of x, q of x, and r of x. And then, as you can see, I have x minus k here. So when I keep x equals to k, this whole term becomes 0. Let me show it to you. This whole term becomes 0 because k minus k equals to 0. When this becomes 0, 0 into anything is 0, so this whole thing becomes 0, and then we get p of k equals to r of k, because when this whole thing becomes 0, then we have one LHS and one RHS, which is p of x equals to r of x. So the remainder, so if I was asked to find the remainder, find the example, so you can take this as an example. Find the remainder when x minus 3 is divided by x square minus 3x plus 6. So what you can do is, so just so let me consider division. Let me construct. So I'm doing a construction. So this construction is totally different. You don't think about the geometry construction. So I'm going to construct a division algorithm. X square minus 3x plus 6 equals to x minus 3. Oh, okay, fine. I thought my video was blocking the screen. Equals to x minus 3 into q of x plus a. So what is a here? A is remainder. So as I told you, remainder is always lesser than the divisor. So if I have the divisor x minus 3, then the remainder has to be a constant. So as you can see here, this part can only become 0 when x equals to 3. So the LHS becomes 9 minus 3 into 3 plus 6. 9 minus 9 plus 6. So the LHS becomes 6 equals to 0 plus a, and the remainder is a equals to 0. So this is a small example, guys. And in the next class, what you're going to see after this, which is going to be posted in maybe within 1 hour or something. So in the next class, you'll be getting the basic problems where you'll be getting an intuition what exactly is happening. You got to know the concept, so you'll understand everything. And after the next class, you'll be having advanced problem solving, and then previous year. So factor theorem is just a derivative of the remainder theorem. So what does factor theorem say? In remainder theorem, we had p of x equals to x minus k into q of x plus r. But r equals to 0. So we can just neglect r. So it is just telling that if the remainder is 0, then x minus k completely divides p of x. So it is something like, example, x square plus 3x plus 2 is divided by x plus 1. So the now what I do is, when I keep x equals to, sorry, this is 1, this is 1, sorry, x square plus 3x plus 1 is divided by x plus 1. So when I keep x equals to minus 1, because I want to make this part as 0, because in a division algorithm it would be like x square plus 3x plus 1 equals to x plus 1 into q of x plus r of x. So now if I keep x, if I keep x equals to minus 1, then this whole part becomes 0. That's what I need. I get, so now I get this side is r of minus 1. So we don't need to write r as r of minus 1, because it's only a linear, I mean it's a constant polynomial, because the remainder is always the remainder is always less than the divisor. Because the divisor is like x plus 1, the remainder has to be something like a constant like a, b, c, or d, something. So I'm just writing r of minus 1 as a, and the LHS becomes 1 minus 3. Oh, sorry. Oh, this is 2. I'm really sorry. This is actually 2 plus 2, and this is 0. Oh, I'm really sorry, guys. I got confused. It's x square plus 3x plus 2. So I get 1 minus 3 plus 2, which is equals to 0. Then I have considered the remainder as a, and the LHS, which is x square plus 3x, x square plus 3x plus 2. And when I keep x equals to minus 1, I get 1 minus 3 plus 2, which is equals to 0. Then I get the remainder a equals to 0. Simple proof, guys. So the fundamental theorem of algebra. So guys, if you don't understand, you can just go back 5 minutes or 10 minutes and watch again. There's no reason not to do it when you don't understand. Don't get fed up and then leave, because this is PRMO, pre-regional mathematics Olympiad, and American invitational mathematics examination. It's going to be tough, and you got to know the concept perfectly for solving the problem. So every polynomial function of degree greater than or equal to 1 has at least one complex or real root. So if I have an equation x cubed plus x square plus x plus 1 equals to 0, then I by fundamental theorem of algebra, this equation has at least one root. And every equation of degree n has n roots and no more. So this equation has a degree 3, and because it has a degree 3, it will have 3 roots for sure. So these can be imaginary or real. It can be anything, guys. Oh, I think the screen is getting blocked. I'm not sure. Yes, it's getting blocked a bit here. Guys, just please adjust, because it's getting blocked very little. So now the proof. Let's go through the proof. So in the proof, I'm considering a polynomial a n x power n plus a n minus 1 x power n minus 1, a n minus 2 x power n minus 2, so on till a1x plus a0 x power 0 by fundamental theorem of algebra. So as you can see, the point number 1, by this one I can say that this equation has at least one root. So I am proving this equation. I'm proving this term. I'm proving this thing. So by the first one, I get that uh, this equation, this polynomial, has at least one root, and I'm considering the root as alpha 1. So I can write p of x equals to x minus alpha 1 into q of x. So now, because I've taken 1x common from this, then I say that q of x will have a degree n minus 1. And similarly, I'm going to write q of x, because even q of x is a polynomial, and every polynomial greater than or equals to 1 will have a root. So again, I can write q of x as x minus alpha 3 into q of 1 into x. So q of 1 is another thing, like for p of x, we have got q of x here when we have taken x minus alpha 1 as a root, and for q of x, we are taking x minus alpha 2 as a root, then we are getting q1 into x. So where the degree of q1x is n minus 2, because the degree of this is n minus 1, and we are taking 1x out of the n minus 1, so we will have this degree as n minus 2. So similarly, we can write it like this, and so on. So I'm writing until so we have got that. So in this one, as you can see this term, that we are going to have one root at least for a polynomial greater than or equal to 1. So at last we will be ending up into x minus alpha, we're going to end up at x minus alpha n. See, we are going to see, first we had q of x, and then we are decomposing the q of x as x minus a2 into q1 of x, and again we are decomposing q1x into x minus 3 into q2x. So it's going to decompose more, and we're going to get something like this. Some people might be wondering, why do we have an? Because here we have an, because when you multiply all the x here, you get x power n, but you don't have, so this is a leading term of x power n, what we missed during factorization, and that is an. An can be 1, an can be 2, an can be anything, it can be imaginary or anything, doesn't matter. We say that we have only n roots instead of n plus 1 or n plus 2, because there are no other values of alpha 1, alpha 2, alpha 3 up to alpha n which satisfies p of x equals to 0. See, so now one second guys, I'm going to erase it, so it's so pretty more looking, it looks better. One second guys. So when I keep something, so how, okay, you would be like asking, okay, you told me that there are n roots, so what if there's another root which satisfies? Okay, let there be any other root. So instead of alpha 1, alpha 2, alpha 3, just keep x equals to beta. So you get beta minus alpha 1, beta minus alpha 2, beta minus alpha 3, so on, beta minus alpha n. In this case, you'll be saying, so there might be some value which is equal to, maybe this term equals to 0, or this term equals to 0, or this term equals to 0. So one thing what you have to remember is, if b equals to alpha 1, then there'll be then we have already considered that alpha 1 is a root. If b equals to alpha 2, we have already considered that alpha 2 is already a root. So if you keep any other value except alpha 1, alpha 2, alpha 3, the equation p of s cannot be 0. That's obvious. I have even explained here. So there cannot be any other values except alpha 1, alpha 2 up to alpha n which satisfies this. So a theorem, so if I have an equation like so example, I have x minus root 2 minus root 3 as one root. Okay, fine, one second. So I have one root as x minus 2 plus root 3. The other root has to be x minus 2 plus root 3. Sorry, x, sorry, my bad. X minus 2 minus root 3. So listen to me first. From this I can say that 2 minus root 3 comma 2 plus root 3 are the roots. All these, so here we have something like root irrational. So instead of irrational we can have imaginary. All these, this is a really simple proof what you can do by division algorithm. Irrational and imaginary stuff, imaginary roots always exist in conjugate pairs. So don't get confused by the word conjugate. So conjugate means if one root is 2 minus root 3, the other root will be 2 plus root 3. So I have given an example. If one root is p plus iq, I is nothing but iota, where iota equals to root over minus 1. So as we know that we only know the values of 1, root 2, root 3, so on till root 4, root 5, root 55. We only know the positive ones, but we don't know the negative. We cannot place root over minus 1 anywhere because we haven't defined it. So now we are defining root over minus 1 as iota. So where iota is root over minus 1. So if one root is p plus iq, then the other root has to be p minus iq. So if one root is root 2 plus root 3, then the other root has to be minus root 2 plus root 3. So now let us go to rational and irrational root theorem. Oh, 1 second guys. There's an issue. Fine. Yeah, fine. So let me go to rational and irrational root theorem. So if I was given a polynomial, so as I told you, the polynomial p of x is written as an x power an minus 1 x power n minus 1, an minus 2 x power n minus 2, so on till a1x plus a naught, where, so I'm taking, so you don't need to learn the proof because the proof is little complicated. So where d of a naught, let d of a naught be the divisors of a naught. So here I only care about two terms. One is the first term and one is the last term. So I only care about two coefficients. One is the last and one is the first. So now I'm taking the divisors of a naught. So what are divisors exactly? So if I have a number 6, so the divisors of 6 are 1, 2, 3 and 6. If I have a number 12, the divisors are 1, 2, 3, 4, 6 and 12. All the numbers which divide 12 are the divisors of 12. So you need to know these simple concepts. So now if the equation p of x has some rational or integer roots, then what the integer and rational root theorem says, it says that all the roots are of the form d of a naught by d of an. So the divisors of a naught divided by the divisors of an. So the roots this term might not be only 1, it can be negative. I mean, this term might not, really sorry guys, this term might not be positive, it can be negative also. It's not necessarily positive as I have given here. And if p of x is a monic polynomial, I have told what's a monic polynomial guys. an is either 1, an is 1. If an equals to 1, then I can what are the divisors of 1? 1 is 1 and 1 is minus 1. So the down part, which is d of an, it can be 1 or minus 1. So the formula becomes the the integer or rational roots will be in the form of plus or minus d of a naught, guys. And all the so if some polynomial has no integer or rational roots, then you might obviously have a naught there. So in a naught, so if the a naught is 5 and it has no integer or rational roots, so we can't guarantee. So if it wasn't given that it has rational roots or integer roots, it has no guarantee that all the roots will be in the form of this, because this is only true for integer and rational roots. So if there's something like root 2 or root 3, we cannot, uh, uh, there's no formula to find the root which is root 2 or root 3 except factorizing all of them. If you want to find any rational or integer root, you can use this formula, which is d of a naught by d of an. So guys, that's it for the lectures, and in the next lecture you will be learning you would be having the problem solving, basic problem solving, and then advanced, and then uh, the previous year. As you can see, we'll be completing by 18 days, so you can ignore the dates here. I don't know if I'm going to start on December 20th. I might start before also, because today is November 1st when I'm recording this lecture. So if I'm done with all the videos by in December, I'm going to start by December 5th, because I need to give an orientation class before at least 3-4 days. And as you can see, there are 4 classes, so you just got to listen to 2 hours a day, and you'll be done with your whole PRMO, AMC, and AIME syllabus. And all of them are going to be recorded, because as you know, the live class is going to have a lot of disturbance and stuff. And as we have done the first lecture, which is polynomials, the second lecture is also going to be of polynomials, and third, fourth is going to be quadratic. So algebra is one of the most important topics. You might at least get 6 questions in IOQM. Even in number theory, you might get 6 questions. But if you look into geometry, the geometry has less theory for IOQM, but you're going to get at least 10 questions. So I have analyzed the 2020 IOQM paper. So we have at least 11 questions from geometry. So 1/3 of the paper is from geometry. So guys, remember to master geometry, and the notes and everything will be posted in the tracker. And I've already sent the tracker link in my Telegram. And if you haven't joined my Telegram channel, oh sorry, if you haven't joined my Telegram channel, it is nothing but t.me. So I will be posting in the description of the video. So it's t.me slash IMO target IMO. So you can join mine and you can get full course, all the courses. And I have already collaborated with Manish Gupta sir, who is an IIT Bombay professor. So even he's working with me, and even he's giving amazing courses. So thank you guys for listening.